welcome to this episode. Today, we will undertake another fascinating journey into the world of technological innovations that are making India more energy efficient. Next stop is an innovation that is taking shape in the textile industry. Indian textile industry is one of the most important industries in India, contributing 2% to India's GDP and being the second largest employer after agriculture in the country. It is also the longest industrial chain in the category of manufacturing industries in the country, which have production of diverse outputs. This presence of varied processes also presents opportunities for newer technologies to replace the older ones. Today's technology is a much-needed intervention to change this scenario.
In order to include major players of textile sector as well as other energy-intensive industries for energy efficiency movement, the Bureau of Energy Efficiency (BEE), a statutory body under the Ministry of Power, launched the Perform, Achieve and Trade PAT scheme. In today's episode, the technology of waste heat recovery through screw compressor will be discussed. A screw compressor is a type of rotary compressor which compresses air due to screw action. The main advantage of using this compressor is that it can supply compressed air continuously with minimum fluctuation in delivery pressure, which is useful in low pressure applications. Under the older process of air compression, during each cycle of air compression, electrical energy got converted to heat energy and got dissipated into air through the cooling towers. The cooling oil used to lubricate the screw element enters through an inlet at 60 to 70 degrees Celsius and gets heated from the heat of the compressor. This mixture of hot oil and air exits through an outlet at 90 to 100 degrees Celsius and flows towards the oil and air separator, and the cooling towers cool the hot oil and air. The hot air gets dissipated into the air. This old mechanism led to significant loss of heat energy and at the same time put a lot of load on the cooling towers as they ended up consuming a lot of energy for regulation of the temperature under desired limits for the process. Meanwhile, the new technology addresses both these issues as it makes use of this waste heat to heat water. Through the introduction of heat exchanger system, 60 to 70% of heat from the compressor oil gets recovered at zero cost. The hot oil is routed through the heat recovery system and its heat is extracted in the form of hot water, which is further utilized in various other processes. This has resulted in reduced wasteful emissions and has made the process more energy efficient.
In any compressed air system, air compressors consume almost 90% of its energy and it is as a waste coming out. Here we have implemented a waste heat recovery system on our compressor. This is the compressor. So we have installed a waste heat recovery system by which we are capturing out of that 90% of waste heat and we are converting it as a hot water generator. This compressor is using the oil and oil is getting heated by capturing the heat. That oil is transferring the heat into this waste heat recovery heat exchanger and by that we are getting almost 60 kilowatt per hour capacity waste heat recovery we are doing. For the monitoring purpose, it is beneficial not only for the carbon footprint but also it is reducing the water footprints also. It is also reducing the load into the cooling tower.
The basic principle of a screw compressor is as the male and female rotors rotate in opposite direction, they draw air in between them. As this air progresses along the rotors, it is compressed as per the decreasing volume space between the rotors. This creates the compressed air that is displaced to the outlet. As a subsequent process, when air is compressed, heat is generated. This heats up the cooling oil, which is lubricating the compressor at the same time. The mixture of hot oil and hot air flows towards the oil and air separator from the screw element and then gets directed towards the heat exchanger unit through the left pipe. It flows counter to the water at 60 degrees Celsius, flowing in the right pipe in the unit. The heat energy from the oil gets absorbed by the flowing water and gets heated to 70 to 75 degrees Celsius. The oil returns to the oil cooler at the screw element. The double walls of the heat exchanger ensures that there is never any intermixing of oil and water. This unique and innovative system has led to three main benefits over the conventional system used for air compression. By using the screw compressor for waste heat recovery, hot water generation at 70 degrees centigrade has been achieved. Energy saving on account of cooling tower has been achieved as the extra heat is now utilized. Considering 930 CFM compressor running at 95% load on an annual basis, the installation of waste heat recovery system will lead to an annual saving of 50.4 tons of oil equivalent energy. It will lead to a monetary saving of Rs 11.5 lakhs per annum. It will result in greenhouse gas emission of 300 tons CO2 per year. The air compression is used across various processes in the textile industry like pneumatic supply for instrument air, air looms in weaving, air padding in dyeing, ash handling system in boiler house, and different machines of spinning and combining. As newer technologies are changing the sensibilities of business and industry, BEE is taking a lead in ensuring that energy efficiency and accountability towards environment are mainstreamed into policy formations across the industries and the business fraternity. The implementation of screw compressor technology in the ever-expanding textile industry is one massive step forward in this direction.
The benefits of this technology are not confined to the textile industry alone, as screw air compressors are used in many other industries as well. This is just the beginning, and as the reports of the benefits of this technology start reaching out to other industries, we can expect a snowball in the coming years to splash across the entire industrial spectrum. This is a great new beginning which promises to shape our future for the better by making industries more energy efficient and environmentally more sustainable. With this bright new dream in my eyes, I take your leave today. But I will come back with another technological marvel that is making our world a better place. You take care and goodbye.